What's up, geeks, and welcome to the channel. Clean and quality code isn't only a code that works, one that provides us with the desired output or result. A high-quality code is a reliable, maintainable, testable, and reusable code. Over the years, many standards, principles, and best practices were introduced and theorized in an attempt to establish the building blocks of object-oriented design. In today's video, we are going to cover 5 principles known as the solid principles. These principles revolutionized the world of object-oriented programming because when combined together, they encourage the developer to create more maintainable, understandable, and flexible software. So, if you're ready to transform your code from good to great, buckle up, as we are going to cover each principle with clear examples and practical insights. Let's kick off with the first principle expressed by the letter S in solid, which stands for Single Responsibility Principle. This principle states that a class should have one and only one responsibility and reason to change. Take this video class as an example. It contains 2 methods: getNumberOfHoursPlayed, which calculates the total number of hours this video was played, and persist, which is the persistence control method to open a connection to and save a video in the YouTube database. Now, if we know that the way the number of hours calculated will not change from one video to another if this class is extended in the future, then the getNumberOfHoursPlayed method is acceptable to be left as is because it deals only and directly with its fields. However, persisting entries into the database isn't something that should be done from the video class, because this does not only assign to this class several responsibilities, but will also force us to replicate this same code snippet when our application evolves and we try to persist another entity in the YouTube model, such as a channel or content creator. Therefore, one way to tackle this is by applying the single responsibility principle. This is done by breaking the video class we have into 2 classes. One will remain the video class we know, and the second class will be responsible for video-specific data access methods. As we can see with this implementation, the persistence logic is decoupled from our Java object, granting this new class its sole purpose, which is accessing the video table whether to persist, update, or retrieve rows from it. Notice that there is still something to be done with this class if you really want to apply the single responsibility principle correctly. Opening the connection to the database can be segregated into another class. Why? Well, what if we decided in other parts of our application to use this same piece of code but with a different user, or to establish a connection but to a completely different database management system? We should have a class that allows us to do so with the flexibility to specify all of these parameters. And if we were to extract such a class, it should look something like that. I'm not going to dive into the details of this class as I want the principles to be the main focus of this video, but the point here is to understand that each class should have a minimal responsibility to accomplish, and it is only a change in this responsibility that should induce a modification to the class itself. Now, what about the letter O in solid? Well, O stands for the open-closed principle. This principle suggests that a class should be open for extension but closed for modification, or in other terms, we should be able to extend a class behavior without modifying it. Okay, let's add to our video class a category field. We wish to add a new behavior in our application that calculates the respective earnings of each video based on its category. And because we want to use the single responsibility principle, let's create a class whose only job is to do that. This class will contain one public method for now. In this method, we are going to create a switch expression, and based on the category of the given video, the appropriate helper method will be called, and its result will be returned to the user. Now, the problem with this implementation is that if we were to add a new category to our enum, we would have to come back to this class and modify it by adding the missing enum to our switch expression and create its corresponding private method. Problems such as these are tackled by applying the open-closed principle. You see, our class is open for modification, whereas the open-closed principle suggests that a class should be open for extension but closed for modification. So, to solve this, we are going to create a class for each category instead of creating one class for all of them, and copy-paste each private method we previously had inside its respective class. Then we are going to create an interface for these classes to implement. As we can see, all these classes now override the same method and implement the same interface. If we were to add a new category, all we have to do is create a new class and make it implement this interface. We don't have to touch existing classes anymore. They are now closed for modification, whereas our logic is open for extension, as we can add as many categories as we want by creating new classes. Okay, on to the third letter in solid, the L, which stands for the Liskov Substitution Principle. In a conference in 1987, Barbara Liskov stated that an object may be replaced by a sub-object without breaking the program, given that the class the sub-object is based upon extends the first one. This principle forces us to think twice before using inheritance with our classes, as our classes shouldn't be extended only based on the fact that they share something in common. To be clearer on this, let's add another method to our video class and name it playRandomAd, which will play a random advertisement for this video when invoked. Additionally, suppose we have premium videos where no ads play. You see, a premium video is a video. We need all the fields inside the video class we created: the title, the likes, the views, even the getNumberOfHours method, and on top of these, let's say a premium ID. So, what we would normally do is extend the premium video class with the video class. However, you see, in a premium video, as I just mentioned, we don't need to play ads, so to restrict access to the playRandomAd method, we can override this method and make it throw an exception, right? Wrong, because if we were trying to access a premium video inside a list of videos, this exception might be thrown, causing our application to crash. So, what we do in such cases is refactor our code to use composition instead of inheritance, or both of them, as the Liskov Substitution Principle suggests. To do that, we have to create a new class. Let's call it Video Manager, for example. This class will encapsulate all video-related functionalities. Every video will now have a private manager object such that the video class will call both of the behaviors we have, and the premium video class will only call the getNumberOfHours method. Now, having all of these attributes in a separate class, called manager nonetheless, isn't exactly the cleanest solution out there. So in my opinion, a better way to tackle this problem specifically is through the fourth principle. This principle is all about interfaces, and that is why it is represented with an I in solid, the Interface Segregation Principle. This principle suggests that many specific interfaces are better than a general interface, or in other words, interfaces having many behaviors are difficult to maintain and hence should be avoided. Let's take the same example we just had, as I believe some of you may have thought that why are we using composition to solve this problem? Why not just create an interface, put these methods inside it, and then let both classes implement it? Well, take a look at this interface. It stores both methods we need. Let's implement this interface by the video and the premium video classes. As you can see, it didn't really solve our problem, as we still have to override and implement the playRandomAd method by the premium video class. And if we throw an exception, we will be violating the Liskov Substitution Principle we just discussed. We basically fell into the same problem we had. However, what we can do is create two interfaces instead of one. One will store the actions that any video can do, and another will be specific for ads-related functionalities. The video class can now go ahead and implement both of these interfaces, whereas the premium video class will only implement the one it needs. And that is exactly what the Interface Segregation Principle suggests. Specific interfaces are better than one general interface. The last principle, represented by the D in solid, stands for the Dependency Inversion Principle. This principle states that we must depend on abstractions and not on concrete classes. When we created a separate class for each video category while discussing the open-closed principle and made these classes implement the same interface, we actually also applied the Dependency Inversion Principle, but without mentioning it. The idea here is to make other parts of our application or services call abstractions or interfaces instead of concrete classes or implementations, so that when a refactoring to the implementation is required, this refactoring can be done independently of the functionalities that make use of these calls. This can be clearly seen in this example where we pass the interface to the constructor instead of the specific calculator implementations. Moreover, this principle can also be extended to include modules and packages and not only classes. So, suppose we have inside our first module a set of classes that depend on another set of classes present in the second module. To apply the Dependency Inversion Principle, what we should do is abstract the first set of functionalities into interfaces, then let both the first and second set of classes depend on the interfaces we created. You see, high-level modules should not depend on low-level modules. Both should depend on abstractions, and that is exactly what we did here. And that's it for this video. I hope it was helpful. Thank you guys for watching, take care, and I will see you in the next one.